Okay, let's see if I got my mic going. I think I do. Let me start the recording. All right, there we go. Recording has started. Okay. Oh, hold on. I got a little message. Now I think my recording has started. Fabulous. I'm going to do a couple of quick problems. And the question says, given these ordered pairs that are on the unit circle, or not on the unit circle, but given these ordered pairs, find the 6 trig functions. So it's really not that hard of a problem to do. So let's do this first one. Let's say this is our, oh, I always do that. This is our Cartesian coordinate plane. And let's just say this is -4. And way up here is 10. I know that that's not proportional, but that's okay. So if we have an ordered pair, -4, 10, that would be right there. And the question says, use this information to find the 6 trig functions. So the thing that we have to remember is we always drop our from the point to the origin, and then we're going to, the next thing we always do is drop our perpendicular to the x-axis to make our triangle. In trig, it's always from the point to the origin and from the point to the x-axis. Don't ever try to get a reference angle or reference triangle by taking your perpendicular to the y-axis. It will not work. All right, so we definitely want our perpendicular here, so we know that that is a right triangle. Now the thing to remember is we already know 2 lengths of this triangle. We know this side is 10, and we know this side is 4 units. Now we know it's a -4, but we can't have a negative direction, so we're just going to call that it's 4 units long. Well, that kind of 4 ended up looking kind of crazy, so let me fix it. There we go. 4 units long. And we need to find out what the hypotenuse is, so that's not going to be too hard. We just use our Pythagorean theorem. So we have 10 squared plus 4 squared equals our hypotenuse squared, and that gives us 100 plus 16, or 116 equals c squared. So that means c is the square root of 116. Now there's probably a perfect square in there. I'm pretty sure there is. Let me see if I can find it real quick. Maybe not. Oh yes, 4 and 29. Oh, so that means 9 is and 4 is, so all right, so we're going to divide 116 into this. We're going to divide it into 4 times 29. 29 is prime. Yep, so that gives us 2 square roots of 29 for our hypotenuse. Great, 2 square roots of 29. Now we can do our sine, cosine, tangent, cosine, cosecant, secant, and cotangent. So we've got sine, and our theta is always the angle right there. So we've got sine of theta, cosine of theta, tangent of theta. And then we've got, now remember, secant is reciprocal of cosine, so it's going to go here, and cosecant is reciprocal of sine. And I always want cosecant to be reciprocal with cosine, but it's not. And then cotangent and tangent are reciprocal. So I know that the sine is opposite over hypotenuse. So for sine, it's going to be the opposite of 10 and a hypotenuse of 2 square roots of 29. And in a minute, we're going to have to go back and rationalize that, but we'll do that in just a second. Then cosine is going to be adjacent over hypotenuse. So the adjacent of the angle is 4 over 2 square roots of 29. And again, we're going to have to rationalize that. That's a 4, not a, I don't know what that looks like, but it's a 4. And then tangent is opposite over adjacent. So that's going to give us 10 over -4. And this cosine is going to be negative as well. There we go. All right, so now to do the cosecant, we're just going to do the reciprocal of those. So we end up with 2 square roots of 29 over 10. That's why I didn't want to rationalize them first. And then this one's going to be -2 square roots of 29 over 4. And then, of course, that would reduce, and we'll take care of that in just a second. And then this one's going to be -4 over 10. Now, let's take our black marker there, and let's clean up these answers a little bit. 2 goes into 2 once. 2 goes into 10 5 times. So that really ends up being the square root of 29 over 5. So that's good. This one reduces, right, to negative square root of 29 over 2. And this one reduces to -2/5. You always want to reduce to get your answer as simplified as possible. And this one's going to be -5/2 This we have to rationalize. So we can reduce. So we're going to make that 2, and we're going to make that 1. And then we have to rationalize by multiplying by the square root of 29 over the square root of 29. Maybe I shouldn't try to squeeze that all in there, huh? Let's see if I can get a little handy dandy. Hold on, let me see if I scooch all that over a little bit. Oh, I didn't get it all. Hold on a second. Let's go about it this way. Oh, well, didn't mean to do that. See if I can move that over. That's all right. We can go back and fix that other stuff that we got messed up there. So over 29, and there's the square root of it. So that ends up being negative square root of 29, or negative 2 square roots of 29 over 29. All right, and then this was 5 halves. My 2 went over here. I didn't mean for it to. And now we have to rationalize over here. So we're going to reduce first and multiply by the square root of 29 over the square root of 29. And 5 square roots of, I don't know what I was writing there. 5 square roots of 29. I don't think I'm going to be able to fit that other one on here. I'll get a new screen. 5 square roots of 29 over 29. And then that one's reduced, and so we've rationalized and we've reduced everything. So that's what the answers for those are going to be. I was trying to scooch 2 problems on one page, but I think that I underestimated my space issues. So we will do the next one on a new screen. So what I would do is fill in your sine, cosine, tangent, do the reciprocals, and then go back and reduce and simplify and that sort of thing. Now, we should have reduced first, because then we wouldn't have had to reduce twice, but we'll do that on the next one. So let's do one more of these for 7 and 24. Where's my little, there it is. All right, 7 and 24. Our ordered pair, 7 and 24. So this was just going to be in the first quadrant. I'm going to draw my triangle over here. All right, so I've got the ordered pair at 7. We'll call this 7, and we'll call up here 24. And there we go. We're going to draw from the point down to the origin, and we draw a perpendicular always to the x-axis, and our theta is going to be here. So we know this is the length of 7. This is the length of 24, and we got to find our hypotenuse. I know that one's a little kind of crickety looking. So we end up with 24 squared plus 7 squared equals our hypotenuse squared. Ooh, what's 24 squared? Hold on, I got a calculator. 576. I can't tell you I knew that because I did not. Plus 49 equals c squared. And you don't want to, when we get to this point, you don't want a decimal approximation. Now, a lot of times students get these kind of problems wrong, because when they do the square root of 625, if they get a decimal, then they're like, I don't know, they just do a decimal approximation. But you want to leave it in square roots. But in this case, we're kind of lucky. Maybe I should have done this one first. It's a little bit easier. The square root of 625 is 25. So we don't have square roots to worry about. I should have done this one first. It would have been a little bit more straightforward without having all that rationalizing. But by this point in your mathematical career, you should know how to rationalize, and that shouldn't rock your world. If it does, you need to go back and review that. So sine, remember, is opposite over hypotenuse. And the opposite of theta is 24, and our hypotenuse is 25. If that's reducible, of course, you would want to reduce it. And then we've got our cosine is adjacent over hypotenuse. Adjacent is 7 over 25. And then we've got our tangent, theta, and tangent is opposite over adjacent. And that's going to be opposite is 24, and adjacent is 7. Now remember, opposite is the one that's opposite the angle, so that's over there, and adjacent means next to. So next to is the one that's right next to the theta. That's how you remember opposite is the one across from it. Do any of those reduce? I don't think so, so those are our answers. Now remember, cosecant and cosine are not reciprocals. Sine and cosecant are reciprocals. So this cosecant of theta is 25 over 24. The secant of theta is 25 over 7. And the cotangent. See how much easier this is when you don't have to rationalize? Just neater and easier and quicker. Where'd my little thing go? There it is 27 over 24. So our 6 trig functions are really easy to do once you come up with your Pythagorean theorem to find the hypotenuse of the side. A lot of students forget knowing the ordered pair tells you the lengths of 2 of the triangles that you're using for the reference triangle. So that's kind of a little synopsis on how to do those problems. So hopefully that's helpful. Feel free to let me know if you have any follow-up questions or need any help with these types of problems. I know the trig stuff is sometimes hard to work on your own, so just know that you're not by yourself, and I am here to help in any way that I can. Talk to you later.